Okay, so we're going to be talking about some key terms that deal with angles: linear, supplementary, complementary, adjacent, vertical. And basically what I want to do is first have you look at this very common diagram which is presented in geometry, in which you have two parallel lines. You have two parallel lines, two lines that don't intersect on the same plane, and a transversal. And when you look at this diagram, there's a few things that happen. So let's just take a look at an example of a linear pair. So here I have a line. If I have two angles like angles 1 and 2, right, that are added together to form a line, two angles added together form a line, then I could call these two angles a linear pair. So basically, anytime you have two angles, now, if you have two angles that form a linear pair, we know that an angle is, or a straight line, or a straight angle is 180 degrees. So you could also say it's supplementary. You could also say it's supplementary. Remember, we've talked about complementary, which I'm going to save this for the following page. Adjacent would be any two angles, let's say 5 and 6, that share a common side and a common vertex. So both 5 and 6 meet at a vertex and share a common side. So you could say those two angles are adjacent. So for instance, if I made a diagram like this here, and I had three different angles, I could say 1 and 2 are adjacent. I could say 2 and 3 are adjacent, but I could not say 1 and 3. That would be incorrect, because yes, they share a common vertex, but they do not share a common side. So we would say these are non-adjacent. So that's a little idea about adjacent there. Now, vertical angles are created when two lines intersect, right? And they form two angles with a common vertex and two non-adjacent sides, right? So I know that sounds like a lot, but basically we call them like angles in opposite direction, or angles right across from each other. So if you look at 6 and 7, we would say those are vertical. They're right across from each other. And the thing about vertical angles is that they're congruent. And that's a big thing to remember. So for instance, and just to show you, let's say I drew another two lines and I made up an angle. You could see that this angle here, let's do it by same shape to show that they're the same. These two triangle angles here, they're about the same measure. So if I put a protractor to it and measured it, this would probably be 20 degrees, and the one right across from it would also probably be 20 degrees. And here I have two vertical angles. They're not adjacent, so they don't share any common side. They only share the vertex, right? And now I could use some angle addition here. I know a straight line is made up of 180, so if this is 20, this is 160. And if you see, if I've created another pair of vertical angles, because if this is 160, this here will be 160. And then notice I've created here, let's do this in another color, I've created a linear pair because I have two angles that make up a straight line, the 20 and the 160. And since they make up a straight line and they're supplementary, I could also say they're linear. So if you see, there's a lot of relationships between these angles. And I'm going to show a few more examples just so you can totally understand adjacent, non-adjacent. So let's look at a pair of angles. A pair of angles that are adjacent, right? And they're adjacent because they share a common vertex and a common side. Let's call them angles 1 and 2. And let's also make both these angles equal to 90 degrees. And by doing this, I've made this pair of angles complementary. Now remember, we remind ourselves what's 90 degrees because I can make complementary into the C and O into a 90. So these are complementary and adjacent. So they could be more than one, let's say one type of angle. Now I could also draw a 30 degree angle here and a 60 degree angle here. Call this angle 3 and 4. And I could say angles 3 and 4 are complementary, I'm going to abbreviate here, but non-adjacent because they don't share a common side. Another way to do that is, let me just draw a linear pair here. Let me make this 40. This would be, and then let me draw another angle here and make this 50. Now 50 plus 40 is 90. Here I have a pair of another pair of non-adjacent complementary angles because yes, they share a vertex, but no common side. So when you start looking at the angles, you're looking at these linear pairs, that's a big one. You're looking at the measure of them, recognizing that 90 oftentimes gives you complementary. And then as you go through much of this, start to look at this shape here. This is like an important, this kind of 4-angle diagram we draw here. Because what happens is, let's say I just measure one angle here, and that's all I would need to do. Let's say we say this is about 35 degrees, okay? Once I find one angle, I can find all. And I could do that by first using vertical angles. So this angle here and this angle here. And I know these are vertical. These angles right across from each other will be the same. So both of these will be 35 and 35. And I know I've made a linear pair out of these two angles, because here I have a straight line. So here's my linear pair here and here. Draw a real big half circle here to show you that 180. And then all I have to do is use the 180, subtract the 35. 180 minus 30, here's what I do in my head. 180 minus 30 is 150. 150 minus 5 is 145. So I know this is 145. And I know these two angles are both supplementary. No, let's say these angles 1 and 2 here. They're supplementary and they're a linear pair and they're adjacent because they share a common side, right? These two, and just like you said, because I know this is 145, this here will also be 145, and that helps me identify my vertical angle. Now, just to finish off, just to kind of something that'll help you now and as we go forward, and we'll finish what we started with. Here's a line that's cut by two parallel lines. Or I could say a line that cuts two parallel lines. Let's say I say this is 40 degrees. And I know because of vertical angles, this will be 40 degrees. And I know because this angle here and here is a linear, supplementary, adjacent angle, that this will also be 140. And if this is 140, this is 140. And as we go forward in geometry, what we'll see and what we'll show you is that because these lines are parallel and they're cut by the same line, whatever these angle measures are here, will be the same exact measures here. Now that leads us into a whole nother list of angles like alternate, interior, so on and so forth, and we haven't got to that yet, but I definitely think the understanding here is that you know, if you have something that's built by a certain amount of angle degrees and they're parallel, in order for these lines to not intersect, then these angle measures here have to be the same.